All right, let's get started. Well, thank you all for coming for our Google Cloud Day here. My name is Daniel Liu. I'm an enterprise architect with Google. Have been spent about 4 years with Google, but been spending probably the last 15 years supporting state of Hawaii. What we can talk about next is one of the really, really hot topics, AI and machine learning, right? It's been the buzzword for the last couple of years, but extremely important is that in the last couple of months, you probably heard about the ChatGPT stuff, right? That kind of just bring the AI to a whole different level. So we can talk about myself. Also tried ChatGPT too, but it's not just the whole AI. So I did start with some really easy questions. What is 6 plus 2 equal to? And it gave me a really nice answer. It equals 8. So then I said, well, my wife tells me that it equals 7. It replies back, so well, wife is always right. It's 7. So that's my experience with ChatGPT. But that is not just AI per se, right? So what is AI? Anybody can give me an answer for that? Or machine learning in general? Yep. That's a really, really good answer. Did you have a degree in PhD or something? Awesome. I'm kind of curious about why, because AI sometimes is very, very difficult. People have very, very different definitions about AI, machine learning, and what it's the capability of using AI, right? So my purpose for this hour, or for the next hours, I want to make sure that you guys all become expert in AI machine learning, in theory only. And we will have more deep dive session demo coming. Just send me email. It's called askdaniel.com, at google.com, right? So what is AI? So AI is actually living the DNA of Google. Our goal is to make sure that AI is available to everyone on the planet, to make sure that it's useful. I give you many examples of that. But of course, and specifically in the later session, I'll give you some examples of how AI has serving for its purpose, especially for public sector. There are many use cases, and I have probably at least a dozen cases, specifically 2 or 3 of those just for Hawaii will have implemented. So this is our CEO talk about what is machine learning, right? So machine learning is the core, the way how we're rethinking about doing everything, right? The way how it transforms our life. I'll play this video very quickly. It takes a couple of minutes, but it does give you a good taste of like what AI machine learning is all about.
As a kid, I was really inspired by the explorers. I grew up in Seattle, and Lewis and Clark were kind of heroes locally. And I wanted to be an explorer when I grew up. As an electrical engineer, I would always look for new things that we can do that just weren't ever possible. And machine learning and research is an exploration. It feels like an intellectual exploration.
We've definitely seen a big uptake in the last 5 years in what machines are able to do compared to, say, the previous decade or two.
With the advent of a lot more data and a lot more computing power, we really can think bigger and sort of change the game about what kind of models we can envision.
The real world is actually very messy. Hard logical rules are not the way to solve real-world problems.
So machine learning is all about learning from examples.
Rather than writing 500,000 lines of code, we instead have the machine learn from observations about the world.
And we look through a bunch of these examples in the machine learning algorithm, maybe millions, maybe billions, maybe even trillions, to identify the patterns and generalize from there.
In the task of image recognition, we've been able to train models to take the pixels of an image, and from those pixels, learn high-level features.
It starts to learn that if you see a cake and you see a kid, it's maybe a birthday party. If you see a cake and lots of kids, it's very likely a birthday party. That's essentially teaching the machines to do the perceptions that we humans are so natural and so good at.
You realize just how amazing humans are, just how amazing your 4-year-old is who can recognize faces.
Machine learning has really been the beginning of a big revolution in the field of speech recognition.
To teach speech recognition, how to interact with a noisy room. We use real-world sounds and we mix it into the examples that we already have.
Is it cold outside? Is it cold outside? Is it cold outside?
Now, no matter what the noise in the environment, our speech recognition systems can understand what you're saying. They can separate out one speaker from another.
With machine learning, we have now an algorithm that learns how to simulate a human linguist.
A lot of the language that we see today, it's very informal.
Blah, 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 blah. And they say, okay.
Interspersed with emojis and stickers. Now, with Google, we're getting to the point where you can have a much more natural conversation.
Any good Mexican places around here?
Here you go.
The assistant product that we're building at Google uses the best of our machine learning techniques in speech recognition, image understanding, natural language understanding.
That's a promising direction for developing systems that can really navigate the mess of the real world. We wanted to make this an open source project so that everyone outside of Google could use the same system we're using inside Google.
There are lots of people who have made very, very creative uses of it without knowing a single bit of machine learning. So if they have the ideas, they don't need to do the heavy lifting that we've already done.
I saw a cool example where somebody used to have a cat going around their house all the time, so they trained a model to identify whenever the cat was there, and they would turn the sprinklers on to scare the cat away.
This elderly couple in Japan who ran a cucumber farm, and one of the big tasks is to sort the cucumbers into like prickly ones, less prickly ones, straight ones, curved ones, and it's actually a complicated task. So the wife would spend many hours a day sorting cucumbers. So the son picked up a computer vision model and was able to build a system to categorize the cucumbers and sort them automatically. All the time wasted sorting cucumbers is just going to be used in much better ways.
387 million people with diabetes are at risk for diabetic retinopathy. It causes blindness. The way that you can find signs of diabetic retinopathy is by taking pictures of the back of the eye. But there's just simply not enough doctors, and it takes hours for an interpretation. So we trained an algorithm that can read the images right then and there. The algorithm can help the doctors get more people screened for the disease.
The more you see machine learning and the kinds of things it can do, the more you see opportunity for it to improve people's lives.
You can use machine learning to save power at significant scales, even track the spread of diseases and epidemics.
We could use a computer vision model for everyone who's visually impaired.
We could make speech recognizer for everyone on the planet and drastically improve the experience of millions and billions of people.
I don't see any area of science or even of human endeavor that learned systems can't help with.
If you'd asked me a few years ago if a computer would be able to do this anytime soon, I would have said, I don't really think so.
It's very, very empowering to imagine what's going to come.
We're thinking thoughts and doing things that, no man has ever done, and sort of setting forth and setting foot in really new intellectual territory here.
The promise of AI and machine learning is that we can actually produce solutions to previously unsolved problems that will really help people.
All right. So my original plan was not find this 4 minutes video, but find a whole hour video and create an avatar for myself so I can just play that and go to the beach. But that didn't happen. So what is AI? So AI is something that's bigger than a concept, right? It's talking really about how we can create those kind of intelligent machines that can think like human beings, right? Behave like human beings. And machine learning is just a specific field of AI where a system can learn to find patterns and examples in order to make some of those predictions. We have using those technology quite a bit. You saw in the video clips that there are some examples I show you, but later I'm going to show you a very specific 4 area of technology where really using machine learning capabilities to really help state local government. Right, so it is a computer that learns how to do a task without explicitly tell the machine how to do it. Anybody have a programming language? I have learned programming in college. quite like almost half of the room. So what things did you learn in college when you start doing programming? Syntax, that's one thing. Is that flowchart sounds familiar? Before you even start doing any of those programming, you have to put the thoughts of all those possibilities in there, right? So that's why you draw those flowcharts. Tells the machine exactly what to do. But that's very difficult because you cannot think about every single possibility, right? If you're missing one, then what happens? The computer doesn't know how to react to it, right? So you have this big error handling routine, right? That's usually happening. That's in my early days I'm doing programming, where you're giving all those messages. I was lucky enough to, my first job was doing an insurance company, doing some of the programming. There's this big one error handling routine that one time the customer calls, well, what is, Daniel, this one message pops out called Guru meditation. I said, I don't know. I spent all my time troubleshooting, appearing in this flow chart. I draw those diagrams. Well, some of those use cases that you cannot handle, right? So you have this error handling routine. The program did that, thought nobody is going to code that. It hit a scenario, but it happens, right? So he just put this really funny message to that. But machine learning is very different, right? We don't have to tell computer exactly what to do. The computer will learn, just like us, right? We have a very sophisticated model that's running that, and it will do its own learning, and then it can make predictions, make those judgments for us. So it can recognize pattern and data, right? Do predictive analysis, right? We can build those models. It's all those self-service. Now, when we think about AI and machine learning, what Google provides is what we call this end-to-end AI platform. So start from the very bottom. We're talking about infrastructure. Because in order to machine learning capabilities, you need to have the computing powers to do that, right? And then above that, AI is not just in isolation. You need to interact with different systems, right? From very modern architecture to mainframe, the legacy system. So you have this whole framework of using AI to interact with other systems, right? Some other things we're talking about, the contact center AI, the chatbot, right? You may have to talk to a system that's sitting on the mainframe system, right? And then above that, we have those what we call AI products. Those are pre-trained modules. Google have done all the works. So all you have to do is just use those modules. I'll talk about some of those. And then, of course, on top of that is all those use cases, right? One example is, how to use technology to sort cucumbers, right? In Japan, in the medical field, right, help to diagnose diseases. But in state local government, we have done quite a bit of those solutions I'm going to talk about. But let's start with at the very bottom, infrastructure, right? You see CPU, you see GPU. Anybody know what GPU is about? A graphic, right? Because CPU is really good at processing regular data, but for graphic data, you need to using special chips, right? Anybody know what's a TPU? Never heard of it, right? Well, Chris earlier mentioned about that. Google is one of the largest vendors that manufacture our own chips and hardwares. This is Google's CPU that is specifically to process AI machine capabilities. But why do we want to do that? Anybody recognize this guy? Well, if you don't know, that's fine. But he's actually very famous in the AI world, okay? So his name is Jeff Ding. Even back almost 10 years ago, he made this very interesting statement. He'll say, well, if we just recording like a couple minutes on the phone, everybody, right? If we trying to process those information, we're going to exhaust every single CPUs on the planet. But that was back 10 years ago. Do you know how much data we have today? In the whole planet we have. So there's a term we call global data sphere. which is a collective all the data that's in there. So this is 2023, right? We just passed the new year. In about 2 or 3 years, collectively we'll collect about 175 zettabytes of data. Do you know what's a zettabytes? How many zeros that's in there? A lot. I know nobody knows, right? So I try to help you to understand. So I built this chart specifically. When I started my IT career 20 plus years ago, I only know how to spell megabyte, gigabyte. Terabyte is a new term, a brand new term. But zettabytes is 21 zeros. And you all know how to spell that in a couple of years, right? I kind of stopped at yottabytes, that's 24. The reason why is it sounds like to like Master Yoda, like I'm a Star Wars fan. So it's 24 zeros, right? But we're getting to that very, very soon, right? But imagine, go back to the statement I'm talking about, right? If we try to process AI information, right? It's so much data. AI is about the model you build, right? They're like a human brain. But how much, it's like how many books can you read in a year, right? You need to have this very special process to process all the data in order to make AI really accurate, right? So that's why Google is produce its own processing unit called TPU, TensorFlow Processing Unit. What does that mean? So what TPU does is, compared to the regular CPU, it's about 15 to 30 times faster, right? And it really reduces a lot of energy too. Which means that that's like Back to the Future. You travel 7 years ahead of time. I don't know how much data we can collect 7 years ahead of time, but I'm coming back in the past to process a smaller data sets. That is the only way you can process all those AI information, because AI is about, we compare different kind of AI technology, but when looking at AI is about the processing power, how fast can you process all this data, right? Of course, we have to have very good models for it, but it's really about processing all the data in order to get a kind of accurate predictions, right? AI can be complicated, right? It's pretty intense, we're talking about, right? So you need a large computational resource. We need this, right? We're just talking about Google has its own chips, TPUs to process all those information. We go to the future to borrow those chips, come back to process data for today. Right. So you have a lot of data processing, AI model learning, right? And you have a lot of parameters to tune. But then you have to kind of like using machine learning expertise, right? Do you need a PhD to do that? Or can you just maybe have someone to build a model for you that pre-exists? You can just use that, right? And then you can just maybe, based on your own data you need, you can train your own data based on a pre-built model, right? So that's AI. So this is what we're talking about. You can do AI in different ways. If you are really, really smart, have IQ of Einstein, right, with a PhD degrees, you can play with those TensorFlow, building your own AI models. But most of us, we are average folks, right? So we like to maybe just take advantage of someone's already building, Google's already building AI modules for you, right? This is on the AI side, right? So it's all those pre-built models you can use. I'm going to get into details on those, what are those pre-built models here, right? But then somewhere in between, right? Because you can take the existing model, because AI is about what? A continual learning, right? Just like us. We continue to learn, read books, we improve ourselves. So you have that base knowledge that's there, but with my own training, continual learning, I can make this AI work better for me, right? With my own custom data. So this is, again, I'm looking at a whole stack of AI machine learning capability from Google perspective, right? At the very bottom, we're talking about the hardware that we produce, right? Infrastructure that we process all those data. And then a level above that is the AI platform. We can do all type of integrations with different systems, right? Because AI cannot work alone. You need to feed data, receive data from all different places. And then a layer above that, let me just highlight those two, that's very important. The green one is the one that's pre-built modules. We have this for, you can just use it. And then somewhere in between, it's called AutoML in our terminology. That is basically you're feeding your own data to make your model look better, right? So there's a one terminology we're talking about in AI. It's always called a human in the loop, right? You examine yourself, right? AI is never 100%, but we can continue improve that by using your own custom data. And of course, on top of that is all kind of services that we can create. I'm going to talk about specifically 4 solutions that we can provide using those technologies. Any questions so far? Are you almost an expert now in AI machine learning capability? Yeah, question. On the CPU chips, Google has its own, yeah. Thank you, Kenny. So now, specifically, I'm talking about a couple of solutions over here. One is called Enterprise Translation Hub. The second, I'm talking about our cloud video intelligence and the vision API. And the third one I'm talking about is the Doc AI. And the last one I'm just going to touch briefly because we have a separate session talk about contact center AI platform. So what is Google Cloud Enterprise Translation Hub? So NetNet in a nutshell is that we have that capability to take any documents, right? Whether it's a Google Slide, PowerPoint, Word documents, PDF files. That ability you can have those legal documents, textbooks. We have the ability to translate that document into hundreds of those languages very quickly, instantaneously. I was actually in San Diego 2 weeks ago trying to do a demo on translation API. I picked like 5, 7 different languages. I just want to pick like 2-page documents I download, but for some reason I picked the wrong documents. That was by 80, 90 pages long. It translated about 7 different languages. It just goes really, really fast. Imagine if you have a human translators to do all that, 80-page documents, right? That's going to take quite some time to do translations. Now, there's a couple of features in terms of, you all probably using Google Translations. Sometimes, it works great, but sometimes, well, it's not exactly how I want it, right? So I'll talk about this a little bit. But for document translations, there's a couple of things here. One is you can do some of those what I call customized translation, which means that, well, if you are trying to translate, let's say, a legal documents, right, a court documents, that had to be very, very accurate, right? So, or maybe I want to translate a documents that's in the medical research fields. There's a lot of those terminology that's in there. I can actually supply a specific set of vocabulary that is in that specific fields, right? So not only that, as I mentioned earlier, there's a process called human in the loop. If you do all those translations, right, we can actually put in the confidence score that's in there. We can have a human that is expert in that particular domain, also bilingual in that language. They can come in to look at documents side by side to do some comparison. If they figure out that particular sentence or that particular vocabulary, even though it translates, okay, but it's not the way how you want it, they can go there and make some corrections. The translation, the AI has the memory. It's just like learning language, right? You're learning Spanish or different language. The first time you may not say this correctly, someone correct you, and then your brain remembers that. Exactly the same idea, right? So it can remember that sets of vocabulary. So the next time the same document pass through, it will be very consistent, because if you even hire 2 professional translators, right, they might have different way of translating the same documents. But not only that, it is also important that when you do this translation for documents, you have pictures, you have colors, you have the different layouts that's in there. We can maintain that layout. So if you have a textbook, for example, we're using this in the education field. Sometimes you have new immigrants comes in, they don't speak English, right? But they trying to help their kids from their homework. But they may know math, physics, but they cannot help them because it's written in English, right? So we can actually translate the children's textbook into a different language, but without losing all the pictures and layout. So parents actually, oh, I know this. They can help their kids on their homework, right? And it's really easy to adopt. So I'm just going to show you a really quick demo on this one. So this is our Enterprise Translation Hub. I just pick a document randomly, and I pick like 7 to 5 different languages. As you can see that I have translated this into simple Chinese, traditional Chinese, right, Greeks, and there's a few other languages I just picked earlier. I translated into Hawaiian too. The good thing is that if you look at this is like a public site insurance forms that you claim forms that you have, right? But it not only translates, right, all the formats that's in there. There's a document download from LA County, but it does not lose its format. It does that really quickly, right? So all I have to do is go there. It does that translation. I can download those. I can email those. I can also maybe send those to someone to review that. So this is just Enterprise Translation Hub in a nutshell. Really, really simple technology. All you have to do is just grab your document, right, and then select the sets of language you want to translate. This is great for government, especially whether it's election comes, you have documents, especially Hawaii. We have multiple conversations, with a lot of agencies. They want to have those official documents translated in a different language so that their citizen can read those. So that's the first technology I'm talking about. Pretty simple, straightforward, is it? Right. The second one talking about is the calls video intelligence and the vision. So this really have to do with whether you're taking some pictures, whether you have some video emotion, right? That ability to analyze videos and be able to extract information out of those to do some type of analysis, right? Maybe feed into a more of a relational database for analysis, right? So I'll give you 2 examples for that, how we do this, right? This is for City of Memphis. I think Raymond earlier talked about this a little bit, but I want to show you a really quick demo, right? So for the cities, right, they're not like a Hawaii, warm, nice weather. You have the winters, snow covers, so the road is really easy to get damaged. You have those potholes that's in there, right? They already have those maintenance cars that go through all the cities, right? But how do you figure out where the pothole is, right? So a lot of time you have the maintenance car, someone manually drive the car around the city to figure out where things are, or maybe have citizens report on where there's a pothole, so they go there and fix it. But imagine using the same technology, right? You just put on your videos in a maintenance car, drive across all the roads in the city. We're using AI to recognize what is a pothole, right? Severity and all that. Combine them with Google Maps so we know exactly where the geolocation is. That makes it really easy for the city to really scheduling, understanding the road conditions across city, where the pothole is, so that you can fix them really easily. Imagine if it's a manual work, it is going to take forever to do it, right? The second example we're doing, I think Ed Sniffen talking about earlier, for the Climate Insight projects. We actually have a demo on the later session showing some of those climate insight analysis. But there's a separate project in parallel. We're talking about Vision Zeros, to looking at from a safety analytic perspective. One of the tasks we're trying to do is to, in those intersections where we have videos to collect from University of Hawaii, to analyze those data, right? We have cars that go through it, pedestrians and bikers that go there. The ability to go there to analyze those movement understand those intersections so that we can do some of the crash analysis, understand the behavior on those intersections. So I'm just going to show you a really quick demo over here. So I don't know if anybody recognized that particular intersection. Right. So this is where you have all the car, right? It's drive-through. Vertex AI technology by default will just recognize those objects, the car speeds, and all that. So by different time frame, right? So those are all the real-time data that's feeding from those videos, cameras in those intersections, right? But no, of course, you can use that to analyze for the road traffic's intersections. But we can also use this for using AI for future predictions too, right? Understand what are some of the risks, right? And when car accident happens in those intersections, to understand what's going on. So that's another example of that. Any questions on this one? Mm-hmm. Yeah, that's a really interesting question in terms of if we translate a book, if there's any copyrights issues. I have a few Googlers in the rooms. Anybody want to take that question? Yeah. Yep. Yeah, another question. Yep. Yeah. Yeah. That's a very good question. But I think, yeah. 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 So I think one thing that's a very good question, right? You're talking about in terms of some of the decisions made by AI. I think that's what, I think the way how we're using AI is really to using AI to help us to assist our decision, right? In terms of, because a lot of things, including DOT, some of the things they're looking at is really from a policy perspective, right? So they can make the right policy. The AI is not in terms to replace human to make the decision for you, but is really in terms of assist. Those are based on the model we build, those are the outcome we think it will be, right? So they can think about in the medical field too, right? So AI maybe help the doctors to, get a better understanding of the x-rays, the things that the doctor may be missing, right? Can really assist on what medicine recommendations to use. But I don't think the AI will replace that recommendation for the medicine, but the doctor will still make that final decision on, but it's nice to have that, right? Because it's same like driving a car, like using Google Maps, right? That's like a whole another topics, whether using autonomous cars to make that decision, right? Thinking about, there are things that I'm always talking about, well, it is help us to make the road safe, right? Because you have all those technology, yeah. All great questions. So the next topic we're going to talk about is the doc AI, right? So I think we're dealing with a lot of those documents, right? All the business start with documents, whether you apply for a loan, right? Whether you apply for a job, there's a lot of applications, you have to fill those forms. Sometimes those are handwriting stuff, right? So we're dealing with a lot of documents. As I mentioned earlier, in the next 3 years, we collectively have like 120 or 30 zettabytes of data. 80% of those data are unstructured data, right? We are usually pretty good at managing what I call relational data, right? Things that's inside of database where things are very nice organized. But dealing with those unstructured data, right, including documents, how can we organize them the way how I used to go, like using Google search to search for the information you needed, right? Especially we're dealing with a lot of paperwork, right, that we have to deal with. So Doc AI in a nutshell is really to look into all those documents, whether it's print documents, applications, handwritings in different language. We have the ability to go into those documents to extract information out, right? So that you can put into more of a relational format. It'd be easy to find and search. That's the whole idea behind it. So if you look at this, right, on the very high level, you have all kind of documents, email, PDF files, different things, pictures and all that. So the ability to getting all those documents, we use machine learning capability, just like you're reading those documents, using our brain, the human eye, right, visually to see those, and then have the ability to comprehend, to understand what is in those documents, right? And then, of course, make this meaningful means not only understanding that, but also make those searchable, right? So it can be organized a little bit better with all those data we collect today. The idea of which it can be using for many use cases. I will give you a couple examples of those, right? Just thinking about any organization today, right? Thinking about a process, whether you apply for employment benefits, whether you go to the DME office, right? There's paperwork you have to do. There are people manually go there to check for your driver license, right? To check for maybe a utility bill, something that you prove that you're a resident for something, right? It's a manual process. Sometimes what takes days, weeks, even months to get maybe a loan approved because you have limited human resource to do those things, right? So that operational efficiency as you're submitting all of your documents, the ability using machine learning capability to getting all those information out, right? Maybe partially help to automate this process, read those information to validate those, use machine learning capabilities. We actually today, for example, for fraud detections, if someone's submitting a driver license, we can tell whether it's a valid driver license or someone ought to have a fake driver license. I actually do have a demo for that if we have time in a different time, right? Really thinking about for our citizen is really produce a whole different kind of customer experience that we have, right? And then of course, not only that, we can provide a whole different insight in terms of customer service to understand the whole process. Right. So what Doc AI does in a nutshell, it's pretty simple. Think about this just like human being, right? We're using some of those optical character recognitions, right? OCR, sometimes you're familiar with. But most of you think about the content management system, they probably only have the ability to read some kind of headers for a document, and they have a relational database that have index to a document. You can kind of do a search, right? But we go beyond that, right? We can actually go into the details of those physical documents, hundreds of those pages to extract information out, right? But using some of those AI called natural language capabilities to understand what's in those documents, right? Sometimes reading those documents can be a bit challenging, so we can, using a process to train in those documents to understand that, right? I actually can give example on the travel app where we're building those. It is actually heavily using this Doc AI technology. This is available, yeah. It's actually being used already during that whole COVID. If you travel to the Safe Travel app for Hawaii, I'll talk about this in the next couple of slides here. Right. So it's using natural language API, right? The ability to really think about, first of all, we kind of talk about understanding not only English, but all different kind of different language, right? The ability to, first of all, classify, because you have all those documents that comes in, right? Just like human being, we need to kind of sort that document out. Oh, this is maybe a application, this is a driver license, this is a utility bill, this is something else. So I can kind of sort things out a little bit first, right? And the second part is going to those individual documents to extract information out, right? So I can understand what's all in there. And then you actually, not only that, you can do other things too, like sentiment analysis detections. I can have confidence score in their trainer documents to understand, oh, this is maybe a W-2 form, this is a utility bill. The ability to sometimes building those what I call confidence score. What that means is that I'll sometimes can teach the machine to make some of those decisions for me in terms of my workflow process. So if it's good enough, then I'll pass it. If the confidence score is not good enough, I will still have a human coming to read again to prove that, right? So that's the idea behind it, right? So this is what I call a life cycle of a document, right? So you will get all those documents that's coming, right? We can kind of throw into some kind of storage buckets in the cloud somewhere, right? And then we're using the Doc AI OCI capabilities, right? The first thing we'll do is maybe do some kind of content classification, right? What kind of document do I receive? Then go inside to read those, extract information out, right? And then I actually can pull those into some kind of storage, can be a database, a relational database. And then from there, you can just search this just like Google search, right? You search those out. Now here is just a process and kind of go through this, right? The first step, of course, is to eyesight, right? Just think about human, read those documents, understand what's in there, right? The character recognitions of those documents. The documents on the left side, if you look at, right, it's just a formatting, have pictures and all that's in there. That's okay. We can train the Doc AI to understand what's in there, right? And then we do classify those content, and then we can kind of decide on, the confidence level of using machine learning, training the models to understand whether it's a pass or whether I need a human to get involved in there to do further examination, right? And then all the information can be extracted easily to understand, and even you have diagram that's in there, that's fine, right? You have sometimes box inside of box for those content that's in there. And then the last part is we can really store those information into some kind of a storage, right? So the same thing I was talking about, not just Doc AI, for DOT as we analyze those traffic data through camera, right? So we can extract all those critical informations and then put into our, we call like a BigQuery platform, and Kenny is going to talk about in the next session. We show some of those demo there. So we can extract all those information from unstructured information, right? Thinking about in this whole platform, you can have all those different type of unstructured data, including documents, including videos, right? Into more of a relational format, and can do all those type of analysis on top of that, right? So this is just, I'm going to give you a couple of examples over here, right? This is kind of like a case management system. People may be uploading their application into a portal, a UI environment, right? So we can identify what kind of document it is, right? Can be passport, driver license, utility bills, applications, right? And then not only that, let's say if you have back and you have a DB2 or ADA database mainframe in the back, we can use API call to validate those information, right? People that send in those information, so you can use API to do a matching, right? To validate those information, right? And then you can add in your own rules on top of that. So let's say someone sent you a driver license, you want to do validation. It looks like a valid driver license, but well, during COVID, your driver license expired, but the person, because the DMV was closed, never get a chance to go to the office to renew their driver license. So it is a valid driver license, but it's expired. you can add business rules on top of that. So, well, yeah, that's a good driver license, but expired. So I need to maybe notify that person, send me the applications to give me another document to prove, right? Maybe his residency. And then I can feed all those information into some type of knowledge base. Then I can decide what to do with those data. Right? Of course, another example is the famous local safe travel app, right? During COVID, I think on average we have about 30,000 visitors come to the Hawaii per day, right? Right ahead of COVID, it downs to only a couple hundred, like maybe 1,000, right? One of the challenge is that when people come over, if they don't prove that COVID negative, they may get locked into a hotel for 2 weeks. If that's the case, nobody wants to come over to visit, right? So it has a huge hit on the local economy here. But how do we resolve that? If someone kind of have their COVID test, show up in the airport as they arrive in the airports here, it's going to take forever to scan through that 30,000 visitors per day, right? It's going to take forever. So the idea of which is take advantage of the dark AI. So when people start loading their COVID test initially, we're using AI to extract those information out, right? Some of those, initially because you have all different health organizations that comes in with different format, the accuracy is probably only about maybe confidence level 60 to 65%, I think. But then we train the model, right? So very soon it reached over 90%. You still have human in the loop. So for those documents, we're quite human to take another look at. But imagine that, 30,000+ visitors per day, if we can handle 90% more using dark AI automation, right? So then people arrive, upload their documents, they have a nice QR code, they can just exit the airport quickly, right? So that's one of the example. Later on, when vaccination card comes, we did the same thing. We have a pre-trained vaccination card, right? And then, of course, you probably remember when you get your first COVID shot, it's all like handwritings. Later, it's a little sticker with the prints in there. So it's a combination of handwritings and a sticker with the prints over there, so we can recognize those, right? The dates when you get shots on that. So that's one of the applications that's take advantage of the dark AI. And within that 18 months or 2 years, we scan about 18.4 million visitors, right? This is another one that we're using for multiple states, right? The improper payment, sometimes they call employment insurance claim. So with COVID, a lot of people lose their jobs, right? So for Department of Labor's, their money is trying to send to the citizen who needs help when they lose their jobs. But there's quite a bit of fraud, right? Earlier you hear Mandarin folks talk about some of the security things. We actually have a lot of people outside of the U.S., pretend to have an address, submit application, trying to getting those money, right? But how do you using AI, or there's multiple technology that's in there, right? One is really when they're submitting their documents, we're using AI to not only extract information, but also validate, right? Somebody's identity, we can actually tell if they submit a passport or their driver license, we can tell whether it's a real one or it's a fake one, right? So we're using this technology to do all those analysis, using AI model to make those predictions, right? Then you can add in confidence score on top of that, right? So if the application looks really good, it looks like a real person, then we can just have the government release those money for the citizen who really needs that, right? But then we can hold down some of those fraud, so make sure that the money doesn't go to the wrong person. But for most of the departments, it's also a big issue for all those states, right? That because government agency was really under this dilemma, right? Because they want to get the money to the citizen who really needs the help, but in the meantime, they don't want to get the money to give to the wrong person, right? So imagine you only have a very limited human resource to process all those documents, then dark AI plays a huge role in this. And the last part of the AI technology I'm talking about briefly, we have a separate session dedicated for that. But I'll just talk about this on the really high level. This is being used quite popular. I think Chris kind of mentioned earlier about the use case we did for Illinois. In a nutshell, the technology is called contact center AI. That's usually for anybody have some of those experience of, whether you're calling your hospitals, calling your airline, right? You have issues, but sometimes you hear this press 1, press 2, right? And you have all those manual in there, but you will never listen to the music, never really get into a live agent to try to help you resolve the issue, right? But imagine that if you have this virtual agent we call, right? Well, talk like a real person in different language, answer the call, hello, how can I help you, right? Or whether you want to maybe do a change for your airline tickets, whether you want to, apply for applications, check the status of applications. The virtual agent can have a very natural way, just like a human conversation. It's not robotic. It's not like the first version of the Arnold Schwarzenegger, the Terminator, right, with this robotic voice. You cannot even tell the difference. Sometimes you really have to, they will have an answer, well, I'm the virtual agent, so they know they're talking to like a robot, not a real person, right? And then you can have this very dynamic kind of conversation, not just a flow chart with a fixed conversation that if you go out of the script, that it doesn't know how to respond to that, right? So they can handle the majority, maybe 80, 90% of the calls, right? So then you leave a small percentage that you really need a live agent to help you, right? But when you get to a live agent, what does the experience usually look like? Well, the person answers the phone will say, well, oh, Mr. Liu, what do you want to do, right? Can you give me your social security number? Can you give me case numbers? No, you have to repeat all those questions. Imagine that you're on the phone already for 2 hours. You are pissed off, right? So you're really mad. And you're probably not gonna be very nice, right? You're talking in this angry voice. Those jobs, I don't envy those jobs because they are dealing with people, they're always getting very angry because they've been waiting on the phone, been holding for 2 hours, right? So this job doesn't last very long. So if I'm the live agent on the job for my first 2 weeks, I don't know how to answer those questions, right? Because easy question, the virtual agent already answered those, right? But AI, we can actually have a called knowledge-based assistant. So as you ask those questions, not only that, in my computer screen, I understand all the previous conversation you had with a virtual agent, the robot, right? But also, when you ask me a tough question, I have a knowledge base can pop all those answers for you, right? And the third component of that is, of course, that we can also provide insights on that, where we can understand from a call center perspective, how many calls do you receive? What's the duration of those calls, right? Is my customer actually happy, right? So you have the AI can actually detect some of those human emotions, understand, from a customer service perspective, right? So that's another way to using AI. So in summary, right, we kind of talk about what is AI, what is machine learning, right? Kind of talk about the overall Google platform end-to-end from infrastructure, right? We produce our own chips to we provide our whole integration platforms. We have those pre-built AI modules you can use. But if that is not good enough, right, using auto ML, which means using your own training data to training the module to make it look even better for you, right? And then I'll give you some of the use cases, right? Doc AI is all about what? Reading all those type of unstructured documents, right? Classify them, read those. We can do all those analysis on top of that. We're talking about CCAI from a context center perspective. Translation is big, right? So we can translate hundreds of pages of the documents into 100 plus of the different type of language instantaneously, right? Without losing its format originality, right? So, and then we're talking about some of those vision, video surveillance AI that we can actually analyze videos, extract all those unstructured information, right? And make those useful into a way we can comprehend. With that, this is the AI machine learning overall solutions. We do have a lot of deep dive demos. If you're interested, talk to us. We can get into the deep specific area. We have a lot of AI specialists that can help you on those. With that, I hope that at the end of are you all AI machine learning expert now, in theory? Awesome. Well, thanks for your time. Appreciate that.